Hey, so we're going to start on weather and climate. So we're really going to dive into climate first, see what affects climate, and then moving our way into weather. So first, what we're going to do is we're going to go to our next page, and you guys should have this from Plan Book, the weather versus climate sheet. And so when we look at weather and climate, you guys don't have this, but this is kind of a working definition that I have for weather and climate, and it's really pretty simple. Like if you go and watch so I have a video here. What's the difference between weather and climate? You can definitely come up with your own working definition, or that's pretty much where you get this definition from right here. So I suggest you guys go and watch that as well. And so if we're looking at weather here, weather is short term, meaning if we're looking at days, weeks, or months, right? You can look on the Weather Channel and they can predict the weather in the short term. But then if we look at climate, we're looking at long periods of time, right? If you're looking at what's Florida going to look like in the next year, or what's the Sahara Desert going to look like in the next year, right? We can almost always guarantee that the Sahara Desert, they're going to see very, very, very little precipitation of any sorts. If we look at the rainforest, like the Amazon rainforest, every year we can guarantee that there's going to be a lot of precipitation. It's going to be tropical weather. It's going to be hot, right? If we look at Antarctica, if we look at the North Pole, uh, we can tell that over the long period of time, right, that we've been around and we've seen Antarctica and those guys, that it's been extremely cold. And those are general trends, right? We can take how is it cold and we can look at the general trend over years, decades, 30 years, 40, 50 years, thousands of years, right? That's our climate, where weather is much shorter than that. So this first one I kind of answered for you guys. So it says the year 1976 was one of the hottest on record. And this is kind of a tough one to start off with. And so what it's going to is it's talking about the year, right? And if I look at a year anywhere, right, if the Sahara Desert happened to get a lot of rain one year, maybe 2 inches, right? That's a lot of rain for a desert. 3 or 4 inches, that's a lot. Now all of a sudden, did the climate change just because of that one year of that odd amount of rainfall? No, right? That now it's something that's interesting, right? We normally wouldn't see that, and it's the highest on record. But at the same time, it's kind of like weather. It's a short term, so 1 year in geologic time, right? In the overall time period of Earth, 1 year is nothing. So we would call that somewhat short term, okay? But then it goes and talks about the hottest on record, okay? And so we get this record, and it's comparing it to years in the past, right? We're looking at 10 years, 20 years, 30 years, however long that humankind has been recording the weather, that's how long we've been looking for, right? And it could be even longer than that. So if we look at number two is saying a very similar thing. In 1992 was one of the coldest summers on record. So again, we're looking at on record. So we're looking into the past. We're looking at a general trend of the heat. Was it cold or was it hot? All right, and we're comparing it to this 1 year. So again, for this one, I put both because we're looking at the weather and the climate. Cities near the ocean tend to be wet. Okay, so if we're being general, right? We're not necessarily looking at one day or the week. Is it going to be wet for the week? No, it's talking about the city. That climate is generally wet. Okay. Florida is hotter than Alaska. Yeah. If we go ahead and if you were to take a guess, if today, which one's hotter, Florida or Alaska, you would know that Florida is going to be hotter than Alaska just because that Alaska is much farther away from the equator, right? And that they're like all throughout time, like ever since you've grown up, you've known that Florida is in fact hotter than Alaska. So we know that's also climate. It might snow in Florida tomorrow. All right, so it's being very specific about things. It's being very, very specific about tomorrow. Is it going to snow in Florida? And so this one's a weather question. It rained on May 8th. So again, it's talking about one day, being very specific. So again, we have weather here. It's supposed to rain this weekend. I would say weather again, very short term. Today it was colder than usual. Okay. So it's talking about today, it's being specific as in a short term, but usual. So again, we're comparing it to the past. It's not necessarily like we're looking at a notebook and we've been writing down the temperatures in a notebook for the past 30, 40 years, but you know the region that you live in, If it's the middle of July and it's 50 degrees here in Illinois, the middle of July, 50 degrees, that is definitely colder than usual because we're looking in the past of our climate normally in July, right? So this, I would say both. Germany is a cold country. So when I think about this general place, this is climate. So climate. Summer's hot. So is our summer hot? Yeah. What makes summer summer and winter winter? One's hot, one's cold. Well, and then the solar differences. It rains every October. So yeah, generally, right? If we look back in the past, is it going to rain again? Right? We can tell that's going to rain in October because if it repeats itself, it will rain. So this is climate. Whoa. Okay, and then our highest one here is the highest recorded temperature in Libya, or of all time, was in Libya, 136 degrees Fahrenheit. This one, I said weather. So this is talking about a one-time deal, a one-day, one-time deal. We got talking about this in class. Could this be both? This isn't for a grade, so if you put both on it, that's fine. I think it's weather just because, like I said, it's the highest recorded temperature of all time. So I guess you'd think of that of all time. So if we go back to your on record, we're looking into the past. I can see where you're getting both out of that. So that's fine. I mean, I can see that. That one's kind of a tough one, but I still think it's weather just because it's recorded on a single day. And it could be just like saying it's raining outside on this day, right? So it's recording that highest temperature on a single day. Okay. So, like I said, we're going to go ahead and get into climate. And so here's our little layers of atmosphere. And so our objective here on this little packet here is to figure out why are there layers, first of all, right? So like you and I, we walk around in something called the troposphere. Well, then there's also the mesosphere, the stratosphere above that, then the mesosphere above that, then the thermosphere above that. Okay, and so why do we have these layers? Well, we're going to learn about these layers because they're divided based on their temperature changes at different heights. And so when they mean different heights, at different altitudes, right? So as you go up in a jet airplane, right, you're going up in altitude. And so that's what it's meaning here. So we're going to make a graph at the very end. But what we're doing here is we're pointing out these key points. So it says the atmosphere can be divided into 4 layers based on temperature variations. The layers closest to the Earth is called the troposphere. Above this layer is the stratosphere, followed by the mesosphere, and then by the thermosphere. The upper boundaries between these layers are known as the tropopause and the stratopause and the mesopause, respectively. So meaning in that order. And so we already know by looking through these objectives, we want to pick out stuff that has to do with the atmosphere, divide it into layers based on temperature changes. And so our first one right here we can look at is the temperature can be divided into 4 layers based on temperature variations. So the layers of atmosphere are divided based on their different temperatures. Okay? So we'll go with that. Let me get this font a lot smaller here for you guys. Okay? Now what's the next one? What's another one we could be doing? So if we keep on the same thing, what's another thing that has to go along with our objectives? Divided into layers. So we have our layers all right here: the troposphere, the stratosphere, the mesosphere, the thermosphere, and then these upper boundaries. So if we have the troposphere, it's saying these upper boundaries between these layers are known as the tropopause. So there's a tropopause, and then we go into the stratosphere, and then after the stratosphere is the stratopause is a boundary, and then we go through the mesosphere, and then at the end of the mesosphere up here, we have the mesopause. Okay, and then it goes into the thermosphere. So maybe we should write something like that down, talk about the different layers that we're actually talking about. So we have, starting with our troposphere. We have our troposphere, and we have our tropopause. This is our boundary. Tropopause. stratosphere, strato, and you can, fast forward a little bit if I'm going a little slow here. Stratopause, and then we have our mesosphere along with our mesopause, and then finally we're in our thermosphere. I know you can't see this right now. I'll go ahead and fix it. Then we have our thermosphere. Okay, so we have these guys, and so remember our spheres are like the zones, and then our pauses are the boundaries, like where they stop, and then a new sphere will begin, right? Okay, so what I'm going to have you guys, I'm going to go ahead and pause this. I'm going to have you try to fill these out. So there's 1, 2, 3 that I'd like you guys to do on your own. I'm going to pause this video here in the next couple seconds, and then you guys are going to do these on your own, and then press play again, and you guys will be able to see what I put up.